Section 5.1, we'll be talking about polynomials and functions. Today we will evaluate polynomial functions and simplify polynomials by collecting like terms. We will also classify polynomial functions. Let's take a look at the warm-ups. Numbers 1 through 4, I'll walk through one of them with you right here. Number 2, x cubed times x to the 4th. When you're multiplying like bases, you add the exponents, so you get x to the 7th. Y to the 2nd times y to the 5th. Again, add the exponents, you get y to the 7th. At this point, you can pause the video and work on the remaining warm-up problems. There are the answers to the rest of the warm-up problems. That is all review on your properties of exponents, which you will need in this chapter. Okay, we'll first start talking about classifying polynomials, both by the number of terms and by the degree of the polynomial. Classifying by the number of terms, another word for term is just monomial. It's basically just multiplication of numbers and variables. So if you look at all these examples under monomial, you only have numbers or variables, and it's all multiplication. Even this example right here, I know it looks like it's division, but that can actually be rewritten as negative 1/4 times x cubed times y squared. So it's really just all multiplication. No addition or subtraction. When you get into addition or subtraction, such as a binomial, like x plus 1, you have two terms. X minus y, two terms, the x and the negative y. Negative x cubed plus 7x, two terms, the negative x cubed and the plus 7x. A trinomial has three terms, and if there's four or more terms, we just call it a polynomial. Even though a monomial, binomial, and trinomial, they're all polynomials, we can further classify those and give them special names, and we will be talking about that a lot this year. Okay, classifying by degree. Degree is just the largest exponent that you see in the polynomial. So for instance, if you look at this example right here, my term of the highest exponent, my term of largest degree is this x squared. The degree is 2, therefore we call it quadratic. Quadratic polynomials is something that we'll talk about for most of the year in this class. If the degree is 0, we call it a constant function. It's basically just no variable there. If the degree is 1, we call it a linear function. Degree is 3 is a cubic function. Degree 4 is a quartic function. Degree 5 is a quintic function. And looking at this example here for a quintic function, you're not going to want to write a polynomial like that because it's not in what's called standard form. I know this form right here looks a little confusing for standard form of a polynomial, but basically what it means is you just put the term of largest degree first. So my x to the 5th is my term of largest degree, so I would write that first. Then I'd put my negative 9x cubed. Then my quadratic term, the plus 3x squared. And then my linear term, the plus x. And then my constant term, the plus 4. Notice how I use all of this vocabulary that we just talked about. This entire page is really just terminology I'll be utilizing throughout the rest of the year. Here are some non-examples of polynomials. The expression is not a polynomial if the exponent is a fraction, if you have a variable in the denominator, if the exponent is negative, if you have a variable under the square root, or if the variable is the exponent. Then those are examples of, or not examples of polynomials. Looking at example 1, we are asked to classify the polynomial both by degree and the number of terms. What we'll practice doing first is writing the polynomial in standard form. So I put my term of largest degree first, which is the 4x to the 5th, and then I descend down, plus 2x cubed minus 3x. So now that I'm in standard form, I see my degree is 5, so it is quintic. And there are 3 terms, so it is a quintic trinomial. In letter B, you'll notice you have some like terms to collect. My cubic terms. Always make sure you simplify the polynomial expression. So 3x cubed minus x cubed is actually 2x cubed. And always make sure you put it in standard form. I should actually put this quartic term first, the x to the fourth, because that's my term of largest degree. And then at the end I'll tack on my constant. So degree 4 makes it quartic. 3 terms makes it a quartic trinomial. And at this point, why don't you pause the video and try letter C on your own, and then resume the video after you finish to check your answer. Okay, you'll see my quintic terms, my x to the fifths, cancel out. Also, my cubic terms, my x cubes, my x to the third, they cancel out. So I'm really just left with 3x squared, which makes this a quadratic, degree 2, monomial, one term. Let's talk about evaluating polynomials. We have done this year, so this really is nothing new. It's just going to look a little different in that they're called polynomials, and that's really it. Remember how we evaluated a polynomial in example 1, letter F, or example 3, letter F. We're just going to substitute negative 2 in everywhere we see x. Make sure when you substitute, you put it in parentheses. And follow your order of operations. Exponent first, multiplication, and then all of your addition gives you 17. Same thing in letter G. We're evaluating a polynomial function. We need to find p of 3. So I can just plug 3 in everywhere that I see x. But what you'll notice here for this problem is you can make your life a lot easier if you first collect your like terms for your function p of x. I notice if I put this in standard form, I have my 1 cubic term, negative 6x cubed. And sometimes it's good to cross it out after you take care of it. I have my 1 quadratic term, my minus 4x squared. And then if you look at my linear terms, x minus x, they cancel out. So they go away. I'm just left with my constant term plus 13. So it's easier to work with this. I have less work to do. I really only need to substitute 3 in for 2 of these x's now. Negative 6 times 3 cubed minus 4 times 3 squared plus 13. Order of operations, I do my exponents first. Negative 6 times 27 minus 4 times 9 plus 13. Then my multiplication. Negative 162 minus 36 plus 13. Negative 198 plus 13 gives me negative 185. Okay. Here you see I bounce around from, to different checkpoint problems. At this point you should pause the page and pause the video, work on C and D on this page and skip to the end and work on numbers 1, 2, and 3 of the checkpoints on the back page of section 5.1. Okay, there are the answers to the first 4. You can go and check your answers, and I'll talk over the last one here with you, number 3. We collect our like terms. Now this one looks a little different because each term has multiple variables. So you can still collect your like terms. The 2x cubed y and the 5yx cubed are like terms because the variables are the same, even though they're a little out of order. So 2 plus 5 is 7 x cubed y. You'll notice my next terms that are like terms are the xy to the fourth, xy to the fourth, xy to the fourth, and the coefficients are 4, -1, -3. 4 minus 1 minus 3 is 0, so those just cancel out. And I'm left with one more term, plus 3x squared y squared. On to the closing questions for the last page here. Go ahead and pause the video and work on these, and then resume playing to check your answers. Okay, I'll quickly discuss these closing questions, particularly number 1. It says, is 1 a polynomial? Well, 1 can be rewritten as 1 times x to the 0, since x to the 0 is just 1. So the degree is 0, which makes it constant, and there's just one term, so that makes it a monomial, constant monomial. Numbers 2 and 3 are review from functions. Number 2 is a function. Number 3 is not a function, since the x-coordinates repeat with a different y-coordinate. Your homework, page 208, 2 through 26 even.